Greetings from Goblin Valley, Nissedal, Norway. I'm here, so you don't have to be. Today I'm going to talk about the dotRDA 24mm single post squonk ready RDA from dotMod. And as my latest RDA reviews, this will not concentrate on the technical stuff. Other people has done brilliant reviews of this and showing you everything there is. So I will, per usual, concentrate on the airflow review and airflow patterns and give you a coil placement tutorial. Now, what is the right place to put a coil? I've had lots and lots of feedback, and those who love what I'm doing prefer the fuller flavor experience with all the flavor notes and a cooler vape and lots of it. The people and guys and girls who hate what I'm doing usually prefers dense, hot vapor with some spatter on the lips for the higher notes, and most of all in the vapor the middle to bottom notes of flavor. So today I will also tell you the absolute wrong place to put your coil. So I'm here for every one of you. Let's go to close-up and we'll look at schematics, and we'll look at footage, and we'll look at schematics again to solve this riddle. And yeah, let's get going. Let us do this stuff as quick as we can. This is the box with the dotMod logo. This is the back side. Freeze your frame if you want to read what's behind. The single thing you want to notice is bottom feed pin set, 3 pieces. This information tells you that if you are going to change this into a squonk RDA, there are 3 parts you need to change. This is what's inside the box. In this glass jar you will find your RDA and the O-rings. In this glass jar you will find 2 Clapton coils, don't use them. And you will find the spare parts for squonking. This is the key for opening the RDA, and this is the Ultem grip tip. And when you remove this stuff, you will find your certificate of authenticity inside this box and the serial number. Obviously the key and gold plated, of course, and this is the Ultem grip tip. This is the contents of the glass jar. Let's just remove these Clapton coils. And notice, if you have to replace your pin and go squonking, you have to replace the contact pin, you have to replace the screw, and you have to replace this spring. And this is the glass jar with the O-rings for replacement. There's a bunch of straw on the bottom of this glass, and this is the RDA itself. We'll change lens on the camera and look closer on it. And here it is. There are 2 airflow channels that can be regulated by turning the inner top on this gnarled surface. You get this RDA in gold and black, and let's open it up. And here you see the 4 parts: the drip tip, the cap, and the barrel, and the deck. The deck is gold plated brass. The drip tip has a is a screw-in type. As you can see, the top cap has 3 airport slits, so you can use this in a single coil mode. Both the cap and the barrel is anodized aluminium, so the barrel and cap will differ in outside color, and the deck will always be gold-plated brass. This is the barrel, and this will be our main focus of attention because of the slanted or angled airflow. You have it slanted here on the outside, you have an air hole on the opposite side, and you will also notice that on the inside the air channel is slanted too, if I get the right picture. Let me see. Yes. So here you see that on the inside the air hole is also slanted. This is most important. This is the build deck. The well is 4.9 millimeters deep, gold-plated brass. The way this thing operates is that you turn this screw, and it opens down first, and when you continue to screw, it opens upstairs due to a spring mechanism. So this is a true spring single post RDA, and you see the peak insulator in between. And yeah, sorry for my dirty fingers, I was polishing a mod last night. There you have the mechanism. I will not take this apart, other has done it, and you close it by putting your coils in upstairs first, and then you put your coils in at the bottom and you tighten it with your finger. No key is necessary for this job. Some of you are probably dying to see the underside of this mod, and it looks like so, with the serial number, dotRDA 24mm and the dotMod logo, and the gold-plated contact pin is of course protruding. Yes, let's go on to the fun stuff. This is a drawing we'll come back to. But for now, just remember that the size of your coil and the placement of your coil will decide how much air that can pass under it and come up stairs. And one thing I want you to remember: if the coil thread is thick, this whole plate with the screw will rise the amount of width times 2 of the coil wire you are using. I'll come back to it. I had to take a break there for a sec. One of my cats had a coughing fit, hairball or something. This is the schematics. Yes, it's in scale 10:1, and let's look at some numbers. The air vents has an opening of 16 millimeter squared each, so that gives a combined air intake of 32 millimeters squared divided by the 2 openings. The distance between the center of this post and the inside of the cap is 6.5 millimeters. The height of this is 17 millimeters. The well is 4.95 millimeters deep, and of course this goes all the way down like so. Now let's look at what dotMod tells us we should do on this RDA. They provide two small Clapton coils with 4 millimeter outer diameter. And if you notice the slants in the wall, they are about 45 degrees. I think they're more like 50, but it's really hard to measure that stuff. Now, if we line up this line with the slant line, and we move this inwards until the line is in the center of the air hole, we end up about here. Now, you might argue now, well, that's too high up because the wires are going in here. But here is what happens. Your wire goes in here, and that fits nicely. Then this whole block rises. Then you put your coil in about here, and the center column rises more. And you see, now it fits. It's no problem. So this is where the maker of the mod suggests you put your coil, and we'll do that in the air chamber. Before we go to air chamber footage, let me just tell you that this wire is 1 millimeter thick. That means that this post rises 2 millimeters. And this is a thin Clapton wire, by the way. Very nice coils. And this air gap around the top screw is 50 square millimeters. When this rises 2 millimeters, you're down to 35. And that's approximately this number. If you use thicker Clapton wires, you will not get the flow that this RDA can deliver. But maybe it's your secret goal. In that case, 1.5 millimeter diameter wire, just go ahead. But just know the physics. Now, back to the airflow. My guess is that this point, or my guess was that this point and this point make up for the stream of air, and my theory was that the air would just go straight in, because in the dead rabbit this goes, of course upside down on the dead rabbit, but this goes all the way up, so there is no clear line of sight through the air hole horizontally. The air has to go down, and it does, and in the dead rabbit it goes down 60 degrees. Now in this case you have an opening with a line of sight straight in. My theory was that this would win and you would miss the coil entirely. Now let us test the two theories and see who is right, me or dotMod. Grab some popcorn and your favorite beverage and let's go watch some movie. The vacuum cleaner is on top of the coil and air is coming in from the right. The coil is placed much further in from the side than in actual real life. And this is just an open slit in the wall. This slit is not yet slanted like the one in the RDA. So this is just a basic test, and the coil is of course then relatively much lower placed than what dotMod recommends. And this is a screenshot of the situation. So as you can see, this coil is placed 6 centimeters in from where the air gap in the wall is. And when you have a perfectly rectangular slit with no angled edges, the air, as we have seen in my other tutorials and reviews, just shoots straight in, although the vacuum cleaner sucks air out of this chamber only 10 centimeters maybe above this coil. Now this is the coil at the same place, top of the slit is at the same place, and this is with a slant of 45 degrees from the right. As you can see, the stream is rising, but per my calculation the angle of the stream is only 10 degrees, somewhere between 9 and 12 degrees. You see the flow in varies. I can't get this totally exact, but it's cool to watch. And here you have a still shot of the situation. As you can see, over a distance of 6 centimeters, the jet rises roughly 1 centimeter, and that indicates, if you calculate it, 9 point something degrees. It's probably a degree or two more or less. This is not an exact science, but the interesting stuff here is the distance from the wall to the coil. It's much bigger. In the coil, in the RDA, the coil will be about 1 to 1.5 millimeter from the wall, and then you understand that the coil placed where dotMod wants you to will make this jet miss the coil entirely. So what we have established now is that air from this point and this point travels upward at about 10 degrees angle, and maybe it spreads somewhat out here in the end, but not this close. Let us look at the sizes first. This is a 4 millimeter coil, like the ones this came with. Wherever you place this coil, you see, because you have this distance of 6.5 millimeters, you have a total of 2.5 millimeters in excess that the air can pass through. So this slit is 2 by 8 millimeters, given the 16 square millimeter opening. This means that if you have a coil that is, say, 10 millimeters in depth, you now have 25 square millimeters of passage on the sides of the coil. That means you can get bigger and still not compromise the effectiveness of the airflow in the RDA. If you go at 4.5 millimeters and say you shorten your coil a bit down to 8 millimeters, then you have a millimeter on each side. Times 2 gives you 16. And then you build on the limits of the capacity of the airflow system of the coil. Of course, if you put your coil further down, you get flow on the upside of the coil too. But you still need some flow from below, and I would say that having a clearance of 1 millimeter on each side is the limit you should aim for, no matter what. You see, the problem is when the coil is placed in the so-called right spot or proper spot. You have 1 millimeter of passage here, and you need to guide the rest of the air through here. So if your coil is here or it is here, you need this space on either side of the coil. If your coil is down here, the matter is of course very different. As we have established per experiment, this is wishful thinking. It is not happening. My theory that this straight-in approach would win was also BS. Now, the explanation for this 10-degree, I think, I'm just theorizing, lies in the air coming here and having a slight Coanda effect over this ledge. I've seen that in some engine physics theories stuff. Now, anyways, we have settled on a outer diameter of 4.5 millimeters. Now, where to put it? You will like to have just as much air on both sides of your coil. You would like this 10-degree stream to hit your coil perpendicular. So the center of the coil, if you think it 10 degrees out of alignment, then you have a 90-degree. And if that is the case, if this is your original 12 o'clock, then your flow should hit at 9 o'clock. So if you think like this, 12 at the top, and you turn it 10 degrees out of alignment, you will that the flow hits your coil at 9 o'clock. Yeah, let me see, 10 degrees there. So on the dotRDA 24 millimeter single post, your 4.5 outer diameter coil should be tangential with the top of your well. That is the right spot. Every other diameter, every other place is the wrong spot. And if you decide to go for the wrong spot, I suggest you go for a 5 millimeter outer diameter, and I suggest you put it high up, not at the top like here, but say here. And here is my reasoning. Through this slot you then get air coming in, hitting this wall, and you have turbulence. So the pressure from the outside is pushing air in. This stream of air turns into unorganized turbulence. But in the same manner, this air discovers the lower pressure up here and to the drip tip and your mouth. So this turbulence will again organize. Not as effective as this, but you will get flow around your clapton in some sort of organized fashion, maybe a bit more organized turbulence. It will cool the coil somewhat down, but not nearly as effective as down here. So my suggestion to you for wrong placement will be a 4.5 to 5 millimeter outer diameter coil placed above where we know the jet is coming in. And I suggest you give the turbulence a bit more space, so you have some sort of cooling around your Clapton coils. Now that will give you the deep, dark flavor notes. Some spatter, not very much, but some spatter for the sweetness and the high notes, but most will be dense, thick vapor with a lot of bottom and medium flavor notes in it. So there we have it. Now I please everybody. This is what I want your coils to look like when you are finished with them. 4.5 millimeter in diameter, sitting flush with the edge of the well. And you see the space on both sides of the coil. That is very important, that you maintain that space on both sides. This is the side view. There you see it flush again. Just freeze these images if I'm going too fast for you. And somewhat straight from the top. You see they fill up the space quite nicely. I will try to be as brief as I can. Your criticisms of me has been my videos are too long. I will not change that, but I will try to be more efficient and effective. Now, to you guys who design this stuff, and I say guys because I think you ladies would have done much better research before putting something out in the world. Do a better job and hire an engineer and study airflow, actual airflow. Don't use gimmicky angles and stuff like that and cross your fingers and think your way through this. You can't. Everything about airflow is counterintuitive, and it varies with speed. I am now doing a lot of measurements on flow and speed and boundary layers, turbulent boundary layers and laminar boundary layers. So I have so much data now, and I can't possibly bring all of that stuff to you. And well, maybe I don't want to either, because there is so much work involved in what I'm doing now. Regarding this RDA, I have to compare it to other solutions with slanted or fancy angles on the air holes. This is by far the best. The reason I say best is best because you have the most balanced flavor and the most of it. The reason is you can put your coils in the proper place, and you can have much bigger coils placed correctly than on the Dead Rabbit and the Pulse 24, excuse me, to mention a couple of them. This dotRDA 24 is by far the best. Criticisms of it is in use. If you don't use Clapton coils, it's fiddly to place your coils correctly, because you have to hold both coils and balance them, and yeah, it's a bit fiddly. Secondly, it's easy to over drip it, because the air vents are very low. Those are my actually only criticism of this RDA. Flavor wise, it produces massive white clouds with a totally balanced flavor. And this cloud was from cold. Let's try a bit hotter. Now, all my since I started this, all my old juice flavors, I'm making huge discoveries in flavor notes from old juices, and this RDA has the most, and it's absolutely fantastic flavor-wise of the slanted designs. A proper coiled Kennedy design will be equal to this. But on this RDA you can put big coils in their proper place. And that is a winner for me. And of course it looks stunningly beautiful on a newly polished Sith V2.